Okay, 65 and 66. Let's just do these right here. And they're talking about breakfast. And what do you got? You got an ounce of cereal, which is 110 calories on average, standard deviation of 10. And then some milk. 140 calories for a cup of milk with a standard deviation of 12, although you only have a half a cup of milk. Now, on the two questions, they ask you for the mean. So let's do the mean of the the total, right? Because I call that event T right there. So let's do this. So let's see. The average of the total is going to be, well, just add the two averages together, right? The average for the ounce of cereal and a half a cup of milk, which would be 70. So we're going to end up with 180 is the total on that one. So that's for 65. 66, of course, asks for the standard deviation of the total. So what we would do is we would say, what is it? It's 10 squared plus, well, half of 12, which is 6 squared. And add them up. Take the square root. Bada bing, bada boom. What is it? Let's see. What is this? Square root of, what's that going to be? 136. Let me see what that is. So the answer should be 11.66. Okay. That is for 65 and 66. Let's go to the next one. Number 69. All they ask is whether it's a binomial distribution. So the only thing we have to do is check bins. That's all we have to do, is check the bins. Is it binomial? And the answer is yes. The seeds either germinate or they don't germinate. It's a yes or no question. Yes or no. Are they independent? And we are going to say that yes, none of the seeds influence any of the other seeds when they're planted. And then, is the number set beforehand? And the answer is yes, because she bought 20 seeds. And then, is the success rate the same? In other words, the probability. And they tell you that it's got an 85% chance of germinating. So bins is all taken care of, which means it is a binomial distribution. That's the answer to number 69. 71. Again, they just ask if it's a binomial distribution, and we are just going to check bins. Now, after reading this question, I can tell you that it's not. It's a geometric distribution, but we haven't covered that yet. The whole point is that the one that's violated is the number is not set. You have to say, I'm going to do this a certain number of times, and then go ahead and do it and see how many successes you have. This one says just pick people one at a time until you get a left-handed person. So bins does not work in this case. It is not a binomial distribution. Let's go to the next one. So these two settings for number 73 is, well, is it a binomial distribution or not? We are going to check bins. So let's see. Here, letter A. Does bins work? Well, right here, it's the S. The success rate is the probability. Now, the fact that the attempts differ widely in distance, angle, wind, and so on, well, the probability is going to be different for all of those field goal attempts. So S doesn't work. The success rate is going to be different. Now, what about letter B? National Basketball Association player has 80%. Okay. The free throw attempts in the past, this season it takes 153 throws. Okay. So the number is set. They're always from the same spot. Okay, so again, that probability is going to be roughly the same for each one of those. Independent, okay, one free throw doesn't affect any other free throw. And he either makes it or he doesn't make it. That's a yes or a no. So B works, A does not work for binomial random variable.